Welcome to our Mathcast on intersections, union, and Venn diagrams. Our goal is to help you better understand the concept at hand when you need it and at your own pace. We hope you enjoy this Mathcast on intersection, unions, and Venn diagrams.
Today we will be learning intersections and union. An intersection is when two sets of data intersect or cross paths. The symbol for our intersection is an upside down U, like we have right here.
A union is a combination of two sets without repeating numbers and in order. The symbol for union is a U, like that, because it's union. U!
Find the intersection and union of the sets. Okay, let's walk you through this problem. First, let's find the intersection. Now, to find the intersection, we look for numbers that are the same, like 4 and 5 in these sets. Then, to set up the answer, we put the labels of the sets with the intersect symbol in between them. Then we put the equal sign and put 4 and 5 in brackets. We do this because the numbers are alike in both sets. That is why we are grouping them together. Now, to do the union, you just take the two sets of data and combine them without repeating numbers in order. Find the intersection and union of the sets. Now, we have a bit tougher question here for you. You see, instead of numbers, we have inequalities. Okay, clear one thing up. The line with the X before this really means nothing. So as we look at the problem, we see that in M, X is less than or equal to 7. In N, X is greater than or equal to 0. Now, to find the intersection, we must put M and N together. To do that, we do that by making a compound inequality. To that, we just put the pointless X line thingy. Then put 0 is greater than or equal to X. Then after that, you put then X right here. You put X, which is right here already, is greater than or equal to 7. We did this because it is a representation of all the numbers between 1 and 7 that intersect. Now, to find the union, we must find all the possible numbers that are between M and N. To do that by putting the numbers between 0 and 7, because the first inequality could be anywhere between 7 and negative infinity. And the other inequality stands for any number between 0 and infinity. So, then basically we take out the numbers that are similar in these sets, which is 0 to 7. Find the intersection and union of these sets. So now that we know how to find the intersection and union, we shall try this problem. We see that X is all even integers and Z is all odd integers. To find the intersection, we must see where they cross. Even and odd numbers never cross because there are no even and odd numbers that are the same. For the intersection, X and Z are an empty set. To show this, we used this symbol, or just empty brackets like this. Now to find union, we have to find all the numbers in both sets of data. Even and odd integers are both infinite, so to represent them together, we would say that they are integers. Together, X and Z are all integers, or just integers, because even and odd integers make up all integers.
Now that we have cleared up the last section, now we can start the next section, Venn diagrams.
A Venn diagram is a way to show the relationship between two sets or more sets of data.
Draw a Venn diagram to show the relationship between the sets. Okay, let's do this example. So, we need to make a Venn diagram out of these two sets. Let's make two circles to start off with. Then label one Bob's favorite numbers. And label the other Peter's favorite numbers. Then we take the numbers only Bob likes, 1, 22, and 104. Then get Peter's favorite numbers that only he likes in the other bubble, 3, 99, and 298. Then we take the numbers they both like and put it in the middle, 7, and 93. There we go, we have completed our Venn diagram. Now to the next slide with John!
Find the intersection and union of the Venn diagrams. Now we have to find the intersection and union of the Venn diagrams. These Venn diagrams may look queer, but they do the same thing, show relationships between sets of data. We can see on the Venn diagram that set C does not whatsoever have anything in common with set A or B. We also see that set A is located inside of set B. This means that everything in set A is also in set B, and nothing in set A isn't inside set B. Now all we have to do is make intersections and unions between the sets. Since set A does not intersect, have any numbers that are the same at all with set C, it would be an empty set. Same goes with set B and set C. However, set A and set B do have numbers in common. 1 and 4 appear in both set A and set B, so they intersect at 1 and 4. Now we must find the union for all the sets. Together, as we can see, set A and B have the numbers 1, 2, 3, 4, and 32. 38. This would be their union. Together, set A and set C have the numbers 1, 4, 5, and 9. This would be their union. Lastly, together set B and set C have the numbers 1, 2, 3, 4, 5, 9, and 38. This would be their union.
Now let's do this example. I know it looks a bit wordy, but it's rather simple. All reed instruments are woodwinds. Some reed instruments are double reed instruments. Therefore, all double reed instruments are woodwinds. Use a Venn diagram to show your argument. Now let's make a diagram from what we know from the last slide. We know that circles can be in other circles. To represent woodwinds, we make a large circle. Then, to represent reed instruments, we put a smaller circle in it. And then we put another circle inside, representing double reed instruments, showing that all reed and double reed instruments are all woodwinds. Now we label the circles. The outermost circle would be labeled woodwinds because it represents woodwinds. The first circle inside woodwinds would be labeled reed instruments because it represents reed instruments. The smallest innermost circle would be labeled double reed instruments because it represents double reed instruments.
Thank you for listening to our Mathcast on intersections, union, and Venn diagrams. Please feel free to listen and learn from other Mathcasts on this channel. Thank you for watching!